I'm your host, Sean MacKenzie. Thank you for joining me once again on my channel on data engineering. Now, in our last couple episodes, we took a look at doing an artificial neural network, and we programmed that using Python, and we integrated it into an application, in this case, Microsoft Access, and we made a lot of headway, but some of you might be wondering, well, how can I modify this script to use my own data from my own database and make it useful for prediction there? And so in this episode, what we're going to do is we're going to take that script that we put together, and we're going to change it, and we're going to change the data set that goes into it so that you can see a different set of data loading, and as well some tweaking of different parameters and things like that for a different outcome. Let's get to it. Looking to download the files used in these videos? Make sure to check out the additional links in the description. Okay, so in the previous two episodes, you might remember that we created our artificial neural network using the script here, and the script, we ran it using run Python in our app, and we used data from our app in these two files here. And the app that we used was a Microsoft Access application, and the output was this preferred CSV there. So, and it was compared to the customer test or custom test file there to see how accurate it actually was. And what we scripted was this script here, and we used those two files, as you can see, and we picked out our features that we used to do prediction, and we used those in order to try and find our preferred score. And it was a very, very simple model with one layer, an artificial neural network using the sequential model from TensorFlow. And so what I'm going to do here is I'm just going to drag in two new files that are completely different from the test data that we put through last time. And this is life expectancy data, which I originally believe came from the WHO, and but this data set has been changed quite a bit and modified and updated and things for testing. And so but you can see that it has this high expectancy marker at the end, which is related to how old the life expectancy is in column E there. And so we have a 1 or a 0, which makes it suitable for our binary script here that we wrote. And by binary, I mean it is a 1 or a 0 outcome that we're going to try to predict for each case. And so I'm going to save that file. I'm going to do a save as on our preferred program. You might remember in our previous episode we did data for a preferred program for a bank, and in this case we're going to do a life expectancy database that is receiving data every year, for example, you could pretend. And you can see here we have our two train and test files. And so we can modify our script that we did last time to include our training and test data for our model. Now, generally, your training data might be 2/3 of the data set, and the testing would be the last third. And then once you had your model, you could go and you could do predictions for millions of rows or whatever if you wanted to. But in this case, we'll take one of the fields from that life underscore train .csv. We'll take the under 5 deaths to see if that predicts anything. And so we'll put that as our first, if you remember here, we'll put that as our first feature, and you can see it is column M, and we'll use that feature along with maybe one or two more randomly just to see if those can be predictors of the higher life expectancy. So I'll use alcohol and BMI, and this will be the high expectancy Y field. So this is our target value, and we're going to use that same field in our trained data and our test data, and those are our features there, and here's what we're looking to predict, and that is a 0 or 1 column. And so we're going to be using the same model we did last time, and we'll use 64 neurons and 100 epoch, and we're using a binary cross entropy, which is going to give us 0 or 1, and then we'll have a output file at the end here after we fit our model. And so we'll choose the ID field and the high expectancy field, which is going to be in the output there, and from our predictions, and we'll call our new field, we'll call it life underscore exp, and that'll be our output file. It'll have all the ones and zeros for the test data, which we can then compare against the test data, and then these sections down here were just for plotting, and plotting is going to give us a little bit of an idea of how well our model is doing, because it is possible to create a model that's 90% accurate, but it only predicts zeros. So you have to be careful and make sure that you have a balanced set in there, and that you're actually getting some output that makes sense. So I'm going to paste in here some code. Now this is just for my case, because I'm recording and I'm going to be running some calculations on my GPU for the parallelization effect, which is really awesome. But this is just going to limit the amount of memory that that this procedure will take on my graphics card, because this particular computer only has 4 gigs on the card itself, so I'll just use half of that. So there we go, we got our files, we got our features, and there's our prediction column that we want to predict. And now I know that there are some ISO characters in that CSV which will not work with UTF-8. And so I'm going to put in our encoding here on our train and test data, because the previous file we used did work with UTF-8 and this file does not. And so once I've got my encoding in there, I can hit F5, and let's just see what we get here. And that's going to take a minute to start, and then it is going to fire off there. This is relatively slow, considering that I did put it on the GPU, and that is going to be one of the first parameters that we change, is our batch size. And so right now the default batch size I think is 32, which is pretty reasonable if you're doing pictures and things like that. If you're doing computer vision, sometimes you need a lower batch size. But for when you're doing artificial neural networks on like data sets and you have a graphics card, you can put that batch size quite a bit higher. Oh, there we are, we're done. So this predicted only zeros. So this is not good. It basically said that it was 49% effective, which is the same as flipping a coin, and so that did not work out for us using all of those fields. But what we can do is, so we can go and we can change the input parameters. I'm doing this kind of blind here, so this is a good example of the trial and error that you might do with your your machine learning project. And as I mentioned, we're going to change that batch size so that we can process more at once, because the graphics card is great for the parallel processing. So I'm going to bump that way up to 500, and that's going to do a big batch compared to before, and so it can do way more at once on that card, and that's going to speed it up for us, and you'll see how fast it is now. Now the last features we chose did not work out for us at all, so I'm just going to try it with just one field, and see if we get anything in there. So you can see how fast it goes now. It's just ripping through those epoch, and it's already done. And now we have a little bit of a different outcome. It looks like it was 70% effective. You can see that down in the bottom left there. And it looks relatively balanced between 0 and 1, and it looks like there's some false positives and false negatives, and we're gonna do a little bit more here just to see if we can get it a little bit more accurate. Now that is quite a janky looking accuracy curve, and normally when you have a pretty good data set and you're configured nicely, that will be quite a bit more smooth, and the model loss would be a bit smoother as well, although we have the right shape for our loss, and that's a good thing. So it means that we are learning something, and we're actually getting some accuracy there. We got 70, almost 71%, but we'll go ahead and try some other fields here, and we'll try tweaking the model a little bit as well, just to see how well we can make this prediction work, this classification. So I'll hit F5 on that. I've added diphtheria to it as well, and we can see if that improves our score. I'm still running 100 epoch, and you can see it rips right through those pretty quickly now that we increased that batch size. And there we go. So we're 72%. We got a little bit with having diphtheria in there. So we know that we can see that there's some kind of relation there, and this is a wild diagram again for the accuracy, and the model loss doesn't look that great. It's got the right shape, but we would like to see a smoother shape. Now you can tweak the learning rate, and you can tweak the number of neurons that are in there. The learning rate can make a big difference, especially when you have a janky diagram like that, and you can do that by customizing your optimizer, which we can do maybe in another episode. But the batch size here, I'll switch that back down to 100, and I've changed the number of neurons, and we'll just see if we get some results there. So I can see as it's running, it looks like we're getting a little bit better results. That's 72.6, so we're going up a little bit with some accuracy there, and it looks like it's still pretty balanced between 0 and 1 and what it should be actually predicting. This curve is pretty crazy though, so we could probably do quite a bit more to improve this, and we could add another categorical variable, which probably will help quite a bit. So this is the indicator whether it is a developing country or developed country, and so we'll add that status into our model as well, and just see what we get here. So we're running a very simple model. I think we put 24 neurons in there, and you can see even with that simple model, this will be quite a bit better, I think. So there you go. We've got 75%. So 3 out of 4 times it's going to get the right answer as to whether or not we have a higher life expectancy there. And so that's exactly what we want to see. This is not the best. It's a little bit more smooth than last time, but you can work on it, and you can get yourself a nice diagram so that you can see that it's not chaotic in the way that it learns. And this learning curve looks quite a bit better than before. This is kind of the shape that we want. It's still a bit bumpy there, but looking pretty good. And there's lots of things that we could do to improve this model, including increasing the number of epoch. Now, if you do too many epoch, you might end up in a situation that's called overfitting, so you got to watch out for that. But all in all, that's how you can reconfigure this script for your purposes. Looking for more topics like these and behind the scenes action? Make sure to check out my Patreon. The link is in the description.